what I'm going to be doing just for today, because we had a bunch of students missing, is that I just started recording this program. Like, feel free, like if you want to record it, you can record it. I don't have any issues with that. But today's presentation, I'm going to record it and post it on Iconestoga. That way, whoever wasn't in the meeting is going to have a chance to also, see what was going on today. Do you have any meeting programs for next Monday? I have that we are supposed to have a class next Monday, but I think that's a typo because it's Thanksgiving, right?
Yeah.
Mm-hmm.
So the only thing that I'm going to show you if I come to a meeting is going to be a turkey.
Perfect.
Anyways, guys, so let's get started, okay?
All right.
So somebody asked me if the background with the palm trees in the back, if that was in the Dominican, I don't know.
Yeah.
Looks like it, but I don't think it is. I could say that's up north, like in Yellowknife. And that's for the International Space Station. Who knows? Anyways, let's get moving, guys. So the first thing that we are going to, the first topic that we are going to touch is going to be, okay, so this is what we want to cover today. We want to cover the oscilloscope, which is going to be the very, very first lab that we are going to cover in the shop. So I'm just going to show you the different functions and the different buttons in the oscilloscope. However, this is not going to be enough because Thursday, of course, you will have a chance to get in the shop and to play with all the different settings and with all the different knobs and buttons and things that you will encounter when you use the oscilloscope. Okay, so what I'm going to do, as I promised, I'm going to shut down my video because I want you to be able to concentrate on specifically on going through the oscilloscope. The first thing that I want to show you today, though, is that right on Iconestoga, let me share my screen with you so you can see it. Okay. Sometimes it takes me a second. Doesn't work. Okay. Oh yeah. Okay, perfect. I'm having some issues with trying to chill the screen. Let me see if it's gonna work or not. Okay, so my screen doesn't want to work. I'm gonna try to share my other screen then from here. When it's working, perfect. So what I was going to say, guys, is that right on Iconestoga, something that I did is that I posted the workbook, and I'm going to show you where it is. So the first thing, I give you a welcome back message. Hopefully when you open that up, you are going to be able to see your name and not mine. I got today, I got emails from a couple guys that didn't know where to go. I apologize if you were in that situation. I thought that you were told that you were supposed to be on Iconestoga right from the beginning. And then all the information, because this is an online course, is going to be posted on Iconestoga. And we are going to be doing as well a lot of quizzes. Remember that in level one, I gave you a bunch of quizzes for those of you that were with me in level one. So in level two, I still like to do the same thing, to give you quizzes as we go through all these different lessons in order to, I mean, for you to have an idea on how well you were able to get acquainted with the topic. So, well, right after, I mean, if you need to get in touch with me, just click the link with my email and you'll be able to, you'll send me an email. Usually I get my emails on my phone. So maybe I should ask the college to pay for my phone, you know, because I use it for work.
Hmm.
I'm just kidding, you know, they are not
Hmm.
going to do that anyways.
I'd say give it a go.
But anyways, I would be asking for the latest one, you know, like the iPhone 12 maybe, iPhone 12 Pro, or maybe the Note Ultra.
Hmm.
Oh yeah, sure. Okay, I'm just kidding, man. Okay, so let's get going. So what I want to show you is that if you send me a message, I'm gonna try to respond as soon as possible. But if you see that it takes me 24 hours to respond, that's usually the norm. That's the normal. Okay. On the weekends, I'm not gonna be responding emails because I wish that I could use my weekends to rest. Sometimes I use them to work, but I'm doing other type of work. So right on the content, right on the content, then you have the weekly Zoom meeting. If you are in this meeting, it's because you found the invitation on it. If it happens that I forget to update the web page and you see a different date here, still this link will be valid. And because we are going to be using the same link over and over and over in order to meet every single week until the end of this course. So I mean, you can click on this link anytime, but I will only be here on Monday at 1 o'clock. Okay. Let's keep moving. So today's topic is the oscilloscope. Uh, we are not going to be watching this video together because that's something that you can do yourself in your, I mean, in your own time. And there's going to be a small quiz that I'm going to ask you to do after this class, which is about the oscilloscope. And those, I mean, under this folder, first watch the video after the class, and then please complete the quiz. Okay, so I'm going to be expecting that everyone, each and every one of you, will have a chance to do the quiz to test how much you were able to retain from the class that we are doing right now. Also, like if you have any questions about the workbook, at least the 2018 version, it's been posted here. So all you have to do is just open it. And in case you have any questions or in case you don't have the workbook yet, at least you are not going to be hindered by the fact that you don't have it, you know, like that you don't have a hard copy of it. So what it says here, class video recordings, that's where you are going to find today's video. And probably what I'm going to do is that it's going to be a raw copy. That being said, because the meeting is being recorded, your faces, which are in camera, will be there, you know, because everything is being recorded. So if any of you have any issues, not wanting to be, you know, not wanting to show your face in the video, so all you have to do is just to shut down the camera, and and then you are not going to be seen, you know, like by the other guys while the video was being recorded. Now, that being said, that was a very lengthy introduction. So let's get started. So as I said, today we are going to be getting into the oscilloscope. And what I'm going to do in order to share with you some of the main ideas about the oscilloscope is that I will use multisim, We're not going to be using multi-scene for doing our simulations. The only reason why I am using multi-scene for this specific lesson, it is because the multi-scene has the same oscilloscope, the electronics that we are going to use in the shops. So this is going to allow me to show you all the different buttons that we have to get acquainted with. To begin with, okay, I'm gonna first I'm gonna go through the boring part, which is showing you all the different buttons, right? And we'll do that pretty quickly, actually. So let me stop the simulation completely. So, okay, so the power button that you see right there in the real oscilloscope is going to be right here on top of it, okay? So once you turn on the oscilloscope, it's going to do a self-test. Once the self-test is completed, what you are going to see is just, you are going to see this, okay? So if nothing is connected, so from here, you see that you're just gonna see like a flat line. When the oscilloscope is not connected, that's all you are going to see, just a flat line.
Mm-hmm.
Now, something that I want you to notice that yes, indeed, we are seeing this flat line, but at the same time, right on this key, we have something that is called coupling. So it says channel 1 coupling. And the coupling right now, it says ground. So I can change this ground to DC or to AC. Every time that we are going to perform a new measurement, the recommendation is that we always default back to ground before we set the coupling to either AC or DC. You may wonder, why is it that we like to default it to ground? It is because this defaulting to ground is going to display this zero potential line. So this line right here indicates that the horizontal line is going to indicate in our oscilloscope, it's going to indicate the time, but at the same time, and this other line here, which is the vertical line, is going to indicate voltage. So anything, I mean, voltage is going to be measured horizontally. So we are going to have anything which is above that line is going to be a positive voltage, or above the ground voltage, and anything which is below that line, that horizontal line, is going to be a negative voltage or below the ground voltage. Okay. Now, as I was saying before, the reason why we default to ground is because when we have the ground have a voltage potential which is equal to 0 volts. That's why that all electrical systems are grounded. Why they are grounded? Because all non-conductive metal parts need to have an equipotential bonding to ground in order to make sure that if we develop or if we have any stray currents, that the protective equipment is going to shut down, and people, animals will be safe, from electrocution. So that being said, um, the reason, I mean, as soon as we have this line, okay, I'm gonna clear everything in here. As soon as we have this line here, this is going to be a reference point. This is going to be a departing point. So if I were going to get any signal, let's say that I have a sine wave, and the signal goes up to that point. Now, because the signal goes up to that point, all up to that, to this line is called a division. Because it goes up to that point, I am going to look right here on the channel 1 at what is the voltage scale that I'm using. I think that, I mean, I can see it very well on my screen, but I don't know if you can see it on your screen. But if you can see it, would you be able, please, to type how much voltage do I have right now up to that point? How many divisions do we have?
100 volts.
Perfect. It would be 100 volts because the oscilloscope, it has, I mean, from the ground, which is right there, it have how many divisions? Let's see.
2 divisions.
Okay. Right now, the one that we are measuring, it has 2 divisions. But from this point of view, we got 1, 2, 3, and 4, meaning that the max voltage that I can measure from here, from my ground reference, all the way to the top, to the above the ground reference, would be 200 volts only. Okay, so by the same token, the max below the ground voltage that I could measure would be minus 200 volts. Now, something important to keep in mind is that this plus 200 volts or this minus 200 volts, the minus 200 volts doesn't mean that you have a lack of voltage. That's the meaning. Like if you see minus 200 in your bank account, yes, that's what it means, that you have minus $200. But in the case of electricity, it doesn't mean that you have minus, that you have a lack of 200 volts. It only means that your current is flowing in the opposite direction. Like in the case of AC, okay, let's say like if this is north and this is south, at one single time, your current flows north to south. At the other instant, the current flow south to north. It doesn't mean that this little electron have ceased to exist or that there's a lack of electrons in the system. It only means that it's going back to where it came from. If it came from the north, now it's going back to the north. Kind of make sense so far?
Yeah.
Okay, perfect. Thank you. So anyways, just to keep going with this, guys. So let me just continue to show you, and then we're going to do some measurements, like all the different functions. So again, I told you here, we have the power button, which is right on the top. Here we have the coupling, and we can change this coupling. This ground is going to be our reference, and that's just to make sure that our reference line is going to be right in the middle in such a way that we have the same amount of divisions on the top above the ground that we have right at the bottom. Now, if we want to measure, as I said before, any other quantities like DC or AC, then I have to make sure that I use this button in order to call or to tell the oscilloscope what is it that I want to measure. Okay, there is another key right here, which you can see that it says course. Any ideas on what that is for? Okay, so oftentimes, let me tell you a little trick that I use, okay? Oftentimes, I'm gonna show you, I'm gonna simulate the oscilloscope so you can see, okay, so I'm on DC coupling, so you can see what I use this coarse and fine 4. I'll put this back right here. Okay. I'm going to clean the screen. Okay. So right now you can see everything back here. You can see what we were. So right now you can see the oscilloscope. I'm going to stop it for a moment. But if I wanted to know what is my voltage level, I mean, I could try to determine and say, well, because I have 50 volts per division, I have, let's say the max voltage is going to be like 50, 100, 150 plus a little bit more. That's a little bit hard, you know, to see. That's a little bit hard to determine. So if you know how to use the oscilloscope, I mean, it's a matter of preference. But in my case, what I like to do is that instead of going with scores, I just go into fine. Okay, so I'm going to click here. Can you see that it changed to fine? And you
Yeah.
may wonder, what's the difference? Well, right here on this knob, okay, like this knob right here, that is your voltage scale. So when you have it on coursed, I want you please to notice right there, right here. Can you see there? I want you to
Yeah.
notice right there the change in the voltage scale. You see that it changed from 50 to 100?
Yeah.
So it changed in bit steps. It changed to 100, to 5, to 2. So you have like big jumps in the scale of the oscilloscope. However, when you have the voltage division to find, then look at what happens. That you can fine tune the voltage scale and you can move your signal to whichever division you want to move it to. Like in my case, because I like the number 3, I use fine and I move my, okay, this is at firing. Okay, and I just move my signal to the 3rd division. That way, my life becomes so easy because all I have to do is look at this voltage, which in this case I have 57. So I say 57 times 3. Why times 3?
3 divisions high.
Perfect, because it's going to be like just 3 divisions. Okay. So in this case, I have 57 times 3. That is equal to how much?
71.
Pardon me?
171.
171 volts. And that's going to be my peak voltage. Okay, so that is called my peak. And E peak is equal to E max. Please take note that the oscilloscope doesn't have anything that is called E peak. That language doesn't exist on the oscilloscope. The language or the way that the oscilloscope is going to display it, it is called Emax. So if we go into another, well, I'm not going to show you that key right now. As we go forward, not today, you know, but as we start doing labs in the shop, I'm going to get you to get acquainted with this other function, which is called measure. So you can learn how to measure different quantities like max, minimum, ripple voltage, and you can learn how to measure all these different voltages that you are going to encounter on any signal. Do you have any questions so far? Are we okay?
Yep.
Okay, so moving on, I already showed you that this key here, okay, that knob is in order to change our voltage level. And if we use fine, we are going to be able to fine tune the voltage level or the scale, the voltage scale that we want to use. Something that you are going to be doing on Thursday is that you will keep clicking on that key. Look at what happens every time I click there. Okay, when I click there, then what is going to happen is that right on this bar, the menu is going to appear. Always make sure that when you are taking measurements, this other key that is called invert, it is always off. We want to make sure that the invert is off because otherwise it's going to, I mean, like the positive voltage is going to be displayed as a negative voltage and so on and so forth. So I'll show you. Like with a sine wave, it's not as easy to see. But did you see what happened there? As soon as I click the invert. So we gotta make sure. So what it's doing is, as soon as I click invert, this signal that was negative was switched to be positive. And you may say, well, I can see it yet. And if that is the case, we can switch this to being DC. Okay, like I'm gonna show you with another, okay, I'm gonna show you with the same scope. What I'm going to do is that I'm going to change my power source to DC. Okay. Uh-oh. The computer thinks that I want to do something else. I have to move this out of the way. Okay. So let me just add the wires now. Okay, perfect. So now when we simulate this circuit, let me increase this value a little bit more so you can see it better, 220 maybe. Okay, so we got 120 volts. So again, if we go back, I want to make sure that we are measuring from the right position. So that is my ground. Okay, when I go back from the coupling to measure DC, I can see once more that, well, I have, like in this case, 57 volts per division, and I am a little bit above the second division. That's gonna make it a little bit hard to determine my really 120, so I have two different choices. As I said, I just like to go to the third line. But that's me. You don't have to do what I do. Okay, so I went to the third line there. So now I have like 40.8. So it's gonna be 40.8 times 3. Uh, you can see that I'm not like 100% accurate on my line, but that's gonna give you your 120 volts. Fair enough? Now, what I wanted to show you was that if we click invert, look at where the signal goes. It goes
Mm-hmm.
below the ground. So it is important that you don't get confused and that you have this invert always off. There's not gonna, we don't need it. I mean, for the labs that we are doing. So I just wanted to point that out. Now, something else, I'm gonna have to get back into our AC circuit. Okay, let's get back to AC. And the reason why I want to get back to AC is because I want to show you how you change the frequency on the oscilloscope. When we simulate the circuit, we have our AC. I change this to my liking. Okay, so now I have my AC signal. If I want to know what is the frequency, and that's the only formula that we are going to use today, how do we calculate frequency from the signal that we have on the screen? Well, in order to change or to determine my frequency, I'm going to have to use the following formula. I will use a formula that says that frequency is equal to the inverse of the period, where this is 1, of course, where T, F stands for frequency, while T stands for period, and period in seconds. Okay, so on the oscilloscope itself, I want you please to focus. I'm gonna stop the simulation. I want you please to focus on the following. Please notice right here that we have even another knob, which is called second division. That is here, seconds division. And that is the knob that is going to change the timing, which means it's going to allow you to measure different frequencies on the oscilloscope. As we continue to do the simulation, please look at this. As I start, and I want you to, as I am moving this little knob here, I want you please to focus on that time. Right now is 5 milliseconds. So if I move this, okay, look at what happened to the signal. I change it to 50 milliseconds and the signal changes right away. Why? Because of the frequency. Can you see how I was able to change the signal? It will be easier when you do it in the shop because it's with something physical, it is easier to move. Okay. So you will always try to get a signal that is going to display at least 2 full wave patterns on the screen. That way you are going to get an accurate reading of the period. So this signal that I have on the screen right now, it would be like a pretty nice signal in order to measure the frequency of the sine wave. But you may wonder and you may say, okay, so wait a minute. Okay, I can see the signal. The only problem that we have with this signal, where should I start reading it and where would you stop reading it? In order to answer that question, well, I want you please to notice that we have another knob here, which is called position. So when we move that position knob, Look at what happened to the actual sine wave when I move this knob. Right now, the wave starts right at that point where I put the blue dot. And when I move my knob, look at what happens. I can change my signal to whichever place I want to change it to. Myself, I prefer to change my signal usually to the very first time division. I usually like to change my signal, or I like to move my wave to the very, very first division because it's going to make my life easier. And so let's do that. I'm trying to do this with a pen, with a smart pen. And sometimes I wish, sometimes I try to grab it with my fingers.
Mm.
I really wish that I could use my fingers to do it. Okay, so now, okay, guys, getting back to this. So if we start counting how many divisions we have, okay, right now we have, let me use this color, okay. We have like, we're beginning here, from here to the first one, to the first division, we have 5 milliseconds. From there to there, we have another 5 milliseconds. If we come to this one, we have another 5 milliseconds, okay? So far, I want you please to focus on the following. I want you please to notice that, okay, like if you had a big screen, it will be easier to see. I want you please to see the following. Give me just 1 second to do this. I want you to notice that right here, between these 2 points, okay, we have 1 division. Now, between each division, we have 5 equal subdivisions. That means that if one division is equal to 5 milliseconds, each subdivision is equal to what? 1 millisecond then?
Yep.
Yep, that is right. And we can notice that this signal is falling like on the second subdivision, right? So we have like the first 3 divisions. So we have 5, 10, 15, and then each of the subdivision is worth 1, 16, pretty much 17. So we have 17 milliseconds. In order to measure a sine wave, we have to count 1 full positive pulse and 1 full negative pulse. In other words, 1 cycle. Because frequency, what is it that we measure when we have frequency? The amount of cycles. So 1 cycle is 1 full positive and 1 full negative. Okay? So that being said, then we have that the oscilloscope right now is telling us that the period of this sine wave is equal to 17 milliseconds. If we have 17 milliseconds, because the period has to be converted to seconds in order to be used in the formula, then I will have to divide this 17 by 1,000 in order to determine how many seconds I have. Or I might as well skip the decimal point, which is right there, 3 spaces to the left, 1, 2, and 3 in order to determine how many seconds I have from the total milliseconds that I had, from the sine wave. So in this case, we have 0.017 seconds, which is, so when we get the inverse of that, or when we divide 1 by that value, we are going to get a frequency which is equal to 58.83 hertz. Okay, so the frequency is measured in hertz. Any questions about that?
No.
So far, guys, we're not going to continue. I'm not going to continue showing you more stuff. It's already 1:47 and it's good enough. By now, I hope that this has been a positive interaction. However, before I let you go, so I just want to make sure that we do a little practice, okay? Something that we are going to use in this course is another software that is completely free online. So we are going to be using one that is called multi-theme. Not multi-theme, excuse me. It's called Falstat, falstat.com. So let me put that on the screen for you. So just looking for, I just keep having some issues with my Zoom. Okay, that's fine. Okay, I'm back. Just for a second, the computer locked me out. Perfect. So this is what we are going to use mainly because number one, because it's very, very easy to use, easier than multi-scene. And for our level, it's just perfect. And number two is completely free. Number three, you don't have to download a software to use. And I'm going to be posting simulations as we go forward. Not today, but in the future, you are going to have simulations called the labs that you are going to do. And if you happen to have any questions about or any doubts about any of the labs, because you will have a chance if you want to do the simulation before you come to the shop or vice versa, do the simulation after the shop, then that's going to help enhance whatever we have covered in the shop itself. So in this instance, I'm going to close the switch pretty quickly. When I close the switch, you can see that immediately there are two themes that you are going to see when we are using Falstack. You are going to be able to see how our current flows, and also you are going to see the voltage level. So that's one of the neat themes that I like about Falstat, that it allows you to see how the current flows. Okay, so in this instance, I'm just gonna remove from the oscilloscope, I'm gonna be removing the current, because usually I don't like to deal with current, especially if we are talking about voltage. So now you can see that I was able to delete my current. And at this point in time, we can see the voltage level on the oscilloscope. Because we are using DC, it's going to be just a straight line. If I decide to change, and that's what I want to give you, like a small, that I want you to determine the frequency of this sine wave. So I'm going to be changing this to AC. Okay. I'm going to be using like a different frequency. And you may say, well, but I can see the frequency right there. I'm going to use a different frequency, this one. Okay, so now what I want you to do, guys, is the following. I'm going to stop the simulation. And I want you to determine the following in this case. Knowing that you have a frequency which is equal to 40 hertz, I want you please to determine the period of the sine wave. In other words, how many milliseconds we have from that point to that point. Please determine the period in milliseconds. Remember that frequency is equal to 1 divided by period. So now I want you to determine t in milliseconds. So go ahead, I'll give you a minute. And please post the answers right here. Wow, that was quick. Somebody already answered. That's good. So keep going, guys. Let's see if these guys that answer all right. Everybody seems to be agreeing that it's going to be 25 milliseconds. That's perfect. Okay. So anyways, Thursday, we're going to have a chance to practice. And as I said before, thank you so much for all those of you that answered the question. So Thursday, I'm mentioning once more, we'll have a chance to practice. If you know a friend of yours that was confused, that didn't know how to log into Iconestoga or to Zoom, please tell them that we're going to be here, not next Monday, because it's going to be Thanksgiving. And the only thing you will see here is going to be a turkey. But just tell them to watch this video at least, you know, so they can start having the heads up on how things are going to be happening while we do the class online. Do you have any questions before I let you go?
Yeah, so the people that have lab with you on Thursday, what projects are we getting ready for this Thursday?
Perfect. That is a great question. Thanks for asking that. So my goal is that Thursday, in the 4 hours that we'll be together, we'll be able to complete lab number 1 and lab number 2. If you happen to be quick enough and you can complete the 3rd lab, you are welcome to do so. But the minimum that I want to see completed is going to be 1 and 2. So
Okay.
1 is about the oscilloscope, which is the same thing that we covered today in theory. And lab number 2 then is going to introduce you to AC theory.
Okay.
Yeah. So it is. It had been nicer if we had been able to come to the shop after at least a couple theoretical classes, but it happened to work out this way, you know.
Yeah.
Yeah. So our next class will be about AC theory, and then we're going to calculate different values like peak voltage, as I said before. E max is the same thing as saying E peak. And then we are going to get into the ERMS, then also into E, which is the same thing like the effective voltage.
And I was just wondering too, so we should be good to go to take the quiz, eh?
That we should be good to what?
like good to go to take the quiz on
Oh,
oscilloscope?
yeah. Go ahead. Take the quiz. The quiz is not full marks. It's only a practice quiz, and you can do it up to 7 times. So I want everyone to be able to do the quiz the mark that I want to see that everyone accomplished at the end of the 7th, okay, try is 100%. Everyone should remediate the quiz to 100%.
Okay.
I mean, like if you do a quiz 7 times, I'm hoping that, yes, that you'll be able to get it to 100%.
Hopefully.
Yeah, hopefully. If you can't, then I'll give you more chances to do it.
Perfect.
So without further ado, okay, guys, and without anything else to say, I'll let you go. I'm going to stay online for another minute or so in case you happen to have any questions that you can send me in private or you can send me the group. But it was my pleasure to be with you today. Have a good one.
All right. You as well.
Thank you.
So we won't have a makeup class for like the Monday theory because our communications teacher had said that she might just move our Monday class onto like a Wednesday where we have a huge block of empty time. You won't be doing that.
No, I haven't been instructed to do that.
Okay.
So
Okay.
we're just going like for Monday. Still, what's going to happen? Nothing is going to be missed in the sense that those of you that won't be in the shop this Thursday will be on the shop next Thursday. So with today's class, at least we'll be able to cover the oscilloscope, no
Yeah.
issues. And then like if you the questions that you will happen to have will be covered as we go in the lab that you are going to be doing for the first time, on
Okay.
that week, on the next week.
Yeah. Okay.
Okay.
So our next theory class is 2 weeks from now.
Yes, it is.
Okay. Well, see you on Thursday then.
See you. Thank you.
So is there anything that we should have ready for our first lab if we have one this Thursday?
My recommendation would be read those 2 labs. If you read them, even if you don't understand thoroughly, at least you had a chance to get acquainted with the information which is on its pages,
Okay.
rather than coming to the lab on Thursday and opening the book for the very first time.
Right. Okay.
What tools do we need to bring for our lab? Just like wire strippers and a terminal driver or something?
Just wire strippers, needle nose pliers, and that's it pretty much.
Okay. Perfect.
Mostly wire strippers.
All right. Perfect.
Okay, guys. See you then.